Here is the answer for the day 4 bell work. Question A, write the formula for Charles' gas law. It's V1 divided by T1 equals V2 divided by T2. Remember that when you use gas laws that involve temperature, the temperatures must be in Kelvin. If they're in Celsius, you've got to make the conversions. Question B, a gas exerts a particular pressure inside a 4-liter container, that's volume 1, at a temperature of 25 Kelvin, that's temperature 1. If the gas has the same pressure inside a 12-liter container, that's volume 2, then what must the temperature be? That's going to be T2. So when I underlined the measurements mentioned in the situation, it's V1, T1, V2, T2. It's going to be Charles' law, not one of the other gas law formulas. So start by writing the formula. V1 over T1 equals V2 over T2. Then substitute. V1 is 4, T1 is 25 Kelvin, V2 is 12, and the unknown variable is T2. Now we want to solve this equation for T2. This equation has the format of a proportion, where there's a ratio on the left side, a ratio on the right side. There are various ways to solve this kind of equation. One way is to look for a pattern. Notice in the numerator how if this is 4 and this is 12, that what happened is the 4 got multiplied by 3. That same pattern will be true in the denominator. 25 multiplied by 3 makes this be 75. Another way to solve this is with cross multiplication. 4 times T2 is equal to 25 times the 12. Then you would divide both sides by the 4 to get the T2 alone. That's going to turn out to be 75, just like we figured before. This is a temperature, so the label is Kelvin. Now question C. A gas exerts the same pressure in a 0.25 liter container, so that's volume 1, as in a 1.00 liter container, that's volume 2. The temperature is 60 degrees Celsius when it's in the smaller container. So the 60 degrees Celsius isn't T1 exactly, but it's going to help us get the T1. We just have to change to Kelvin. So 60 plus 273. That result is 333 Kelvin. That's the number we're going to use for T1. Now let's read further. What is the temperature when it's in the larger container? So this temperature is the T2. Now we're ready to choose our formula from our different gas law formulas. This is V1, V2, T1, T2. That's Charles' law. Let's write the formula down. And make the substitutions. V1 is 0.25. T1 is 333 Kelvin. V2 is 1.00. And T2 is our unknown variable. Now we're ready to solve this equation, which, like last time, has the format of a proportion. You could use the pattern technique. In the numerator, 0.25 times 4 makes 1.00. So in the bottom, you could go 333 times 4, and you'd get the answer. The other thing you can do is cross multiplication. That always works for proportions as well. 0.25 times T2 is equal to 333 times the 1.00. You're multiplying one diagonal and then saying equals and multiplying the other diagonal. To get T2 alone, we need to divide by the 0.25. So the result is T2 equals 1,332. This temperature will be in Kelvin.